Hello student, this is Dhanjit and you are watching me on my YouTube channel Reaction Concept. So student, this video would be a very short video. Only few things will be covered in this video. The topic in this video I'm going to cover is comparison between Roult's law and Henry's law. Both these laws has been discussed in the earlier classes. So in these classes I'll make a comparison between these two law and I'll discuss two problems based on these two laws. Okay, one of each. So without any further delay, let us start the session here. So what is Roult's law? This Roult's law says that when a solution of liquid and liquid, that is in the solution, both the solute and solvent both are what? In a liquid state. But in case of Henry's law, it is said that solute is gas in liquid. This means the solution is constant of solute of gas. Here it is, gas is the solute and solvent is the liquid. Both the solute and solvent in this case, in case of liquid solution, both are volatile. Okay, that you should remember. Now what is the laws here stated? You see, if a solution of liquid composition you are considering, then partial pressure, vapor pressure of any component, suppose you have a component A and B, this partial vapor pressure of any component is equal to the PA0, this is the vapor pressure of that component in pure state, into mole fraction of that component in the mixture. This is the mole fraction of A and this is the mole fraction of B in solution phase. Okay, this is the Roult's law. Again, you see, what is the Henry's law for gas in a liquid solution? In this case, you are having a solution of liquid, solvent, and a solute of gas. Gas solute would be over the liquid surface. Okay. According to this law, it is said that when it increases the pressure of this gas, then the mole fraction in this solution of that gas will increase it. That means this pressure of the gas, vapor pressure of the gas, will be directly proportional to the mole fraction of that gas in solution phase. So this you can write as equal to a proportionality constant into mole fraction of the gas in solution. So this is the Henry's law. In the both cases you can see the similarity that vapor pressure of a volatile component in the mixture is proportional to the mole fraction. This is proportional to the mole fraction of that component in the solution. Only difference is their proportionality constant. Here it is the vapor pressure of the pure liquid and it is the Henry's constant. This KH is called as Henry's constant. Both the laws look similar, but it is used for the liquid solution. Roult's law is used for liquid solution, whereas Henry's law is used for gas in a liquid solution. So these are the comparison between Roult's law and Henry's law. So if we write the similarity between these two laws, the similarity will be vapor pressure is of a component is proportional to the mole fraction of the component in the solution. Okay, this is the similarity. If you try to write the dissimilarity, then it will be the PA naught in case of, but pen is not writing, PA naught in case of Roult's law is not equal to the proportionality constant, that is Henry's constant of the Henry's law. These are the similarity and dissimilarity between Henry's law and Roult's law. Okay, now we will discuss two problems based on these two laws. So this is the first question here. In the question it says that there are two liquids are there. Okay, the liquids are X and Y. These two liquids, on mixing these two liquids, it will form an ideal solution. This means that if these two liquids are mixed, it will form an ideal solution. It means that the mixture of these two will follow the Roult's law. Okay, and two conditions are given in this question. They said that at the temperature of 30 degrees Celsius, the vapor pressure of the solution containing 3 mole of X and 1 mole of Y is 550 mm mercury. Okay, but when the 4 mole of X and 1 mole of Y are mixed, the vapor pressure becomes 560 mm. What would be the vapor pressure of X and Y in their pure state? That is asked in the question. So what is the two question? What are the two conditions given in the question? It is said that at 30 degrees Celsius, when you add 3 mole of X and 1 mole of Y, then total vapor pressure, it becomes how much? 550 millimeter of mercury. In the second condition, it is given that when you mix 4 mole of X and 1 mole of Y is mixing, then the total vapor pressure becomes 560 mm. Okay, these are the given data in the question. And what is asked in the question? In the question it is asked there, what is the vapor pressure of X and Y in their pure state? These two values are supposed to be find out. Okay, so let us write the Roult's equation for this condition. Okay, here it is, total pressure is 550, so it would be equal to the mole fraction of X Py naught mole fraction of Y. It will be Px naught mole fraction of X, it would be 3/4, and mole fraction of Y, it would be 1/4. Okay, so it would be 220. If we calculate these things, simplify, then it would be Px naught and Py naught. Number details, equation number 1. Okay, in this case total pressure is 560. Okay, then the mole fraction of X and mole fraction of Y into vapor pressure of the Y in its pure state. This is the Roult's law for this condition. Okay, this will remain as this, and mole fraction of X would be 4/5, and this would be 1/5. It will give you 280 4 into this is the equation number 2. Okay, these two are linear equations. So if we calculate this one, suppose you are subtracting equation 2, you're subtracting equation 1 from 2, then you will get Px equal to 600 millimeter. Now you put this value on any of these two equations, then you will get Py naught equal to 400 mm. I'm not doing this calculation because these are very simple calculation. Okay, so these are the two values that we are supposed to find out: the vapor pressure of X in its pure state and vapor pressure of Y in its pure state. Okay, now we'll so this is the second problem we are discussing here. So what is given in the problem? In the problem it is given that at a watt partial pressure the oxygen will have a solubility of 0.05 gram per liter in water at 293 Kelvin. So in the question it is given that there is a solution of oxygen in water. So solvent here it is water and solute is oxygen gas. Okay, solution is gas in a liquid solution. So in this case we will use what? Henry's law. Okay, so in this question you are given concentration of oxygen gas in the solution in gram per liter. What it is? 0.05. So it is asked what is the partial pressure of this oxygen? What is the partial pressure of oxygen in this solution? So you can use the Henry's law here. So partial pressure of oxygen, it will be the Henry's constant into mole fraction of oxygen in the solution. The Henry's constant, it is given that 34.86. Here it is kilobar. If we convert it into a bar, then it will be 10 to the power 3. Okay, this becomes bar. Now you see in this case it is a mole fraction of oxygen. Okay, solubility is expressed in terms of mole fraction, but it is given in gram per liter. So you cannot put this gram per liter in the mole fraction place. Okay, now you have to convert this gram per liter into mole fraction of oxygen. This concentration term has to be converted to each other. So let us convert it. You say density, it is given the density of the solution. Density of the solution, it is given the 1 gram per ml. This means that 1 ml of solution, mass of 1 ml of solution is 1 gram. Therefore mass of 1 liter would be 1000 gram. This is the mass of solution of 1 liter. So mass, if mass of solution per liter is 1000 gram and mass of solute here per liter, it is given the 0.05 gram, because gram per liter unit is given. Okay, so mass of solvent would be per liter 1000 minus 0.05. This would be approximately 1000 gram. you are supposing this value, because this value is very small compared to the 1000, so you are neglecting this term. Now we'll find out the mole fraction of oxygen in this case. So number of moles of water, mass of water divided by molecular mass of water, it is 18. So mass of water is 1000 gram divided by 18, it will be 55.5 moles. Whereas number of moles of oxygen, weight of oxygen divided by 32, it is the molar mass of oxygen. So mass of oxygen, it is 0.05 divided by 32, it would be 1.56 into 10 to the power minus 3 mole. This is the number of moles of oxygen and number of moles of water in the solution. Now we can easily find out the mole fraction for oxygen in this case. So mole fraction of oxygen would be 1.56 into 10 to the power minus 3 divided by 55 into 5 plus 1.56 into 10 to the power minus 3. So this value is very small, you can neglect this value. Okay, so if you calculate this only term, then it will result as 2.81 into 10 to the power minus 5. This is the mole fraction of oxygen. So in this place we can put this value, the mole fraction of oxygen. So partial pressure of oxygen would be 3486 into 10 to the power 3 into 281 into 10 to the power minus 5. If we calculate this one, then it will come out as 0.98 bar. Okay, you calculate these things and verify this one. This is the solution. So guys, I hope you have understand both these two problems and comparison between these two laws, that is Henry's law and Roult's law. What is the difference between these two laws and the similarities between these two laws? Okay, so guys, if you have any doubt, you can ask me in the comment section below by dropping your comment. And if you have liked this video, then give a big thumbs up to this video, and if you're new to this channel, then subscribe our channel and don't forget to press the bell icon. So guys, this is it for today's class. Thank you.